Jamen, velkommen til dagens første breakout session. I dag på det her spor vil jeg præsentere Cisco HyperFlex. I will switch into English as this is a Nordic group. I know there are Finnish people attending. So my name is Bjarne Madsen. I work with Cisco in a storage solution group. I'm actually covering most part of Europe and primarily all the Nordic countries. So what I want to present today is just one slide on Hyperconverged, just to make sure that we set the scene. What is Hyperconverged? The Cisco second generation Hyperconverged HyperFlex solution. We will go into a little bit deep depth on the architecture, on the features that we provide, and hopefully I will also be able to show you a demo at the end of this session. So I will also make sure that we have time for question and answers. Now we are quite many people, so we will have time for question at the end of the presentation. So Hyperconverged, what is Hyperconverged? On your left side, you see how we traditionally have built data centers with compute, storage, networks, actually connecting a lot of hardware components, SAN, NAS, SAN switches, servers, network. Hyperconverged is actually where we now deliver an appliance-like solution, offering both compute, storage, and now it's Cisco. We also include networking in one single scalable solution. So from a Cisco point of view, the component that we actually build our HyperFlex platform from is not new technology. It's based on our UCS servers, which have been in the market for many years, currently in generation 4. Generation 5 is coming up. And what we actually add is just intelligence in form of hyperconverged software. The setup delivering compute, storage, network, but also the hypervisor. So our solution is based on VMware today, but we deliver that in a box, actually in one platform, where we base the compute storage using standard rack servers. So we do have two different models, whether you want capacity or whether you want compute and less capacity. We actually deliver these solutions with a flexible architecture using the CPU, the memory that fits into your environment. Today we are offering the solution as a hybrid storage solution using both SSDs and spinning disk. But we also have an all-flash solution where all the disks that we use in the setup are flash disks. Second generation, one of the big benefits with Hyperconverged HyperFlex from Cisco is that we also deliver the networking part. So the networking part is what we call our fabric interconnects. It's not a switch, it works like a switch, but this is where we also deliver the storage highway for the communication that is needed in a scale-out hyperconverged solution. So we connect all our servers to our fabric interconnects, and then we just span out to your production network with 4 cables, is what we typically do. But this is always a part of our hyperconverged solution. So if we take a look on what hyperconverged is, we're talking about agile. Hyperconverged is not a platform that you need to spend days on actually implementing. You need to spend hours. So we have already, when we deliver HyperFlex, configured the server with VMware. We have set up what we call profiles in our setup. And very fast in the data center, we are with the installation. Efficiency, flexibility is also a big part of Hyperconverged and of HyperFlex. So I can start very small, that fits my needs today, but knowing that I can easily scale both with storage compute, and one of the unique features, as you will see, scale only with compute if that's what is needed in the setup. And of course, being able to scale your setup, actually fulfilling your needs, is one of the big benefits of Hyperconverged, of HyperFlex solution. So our HyperFlex solution build a new data center, a new setup for your application, whether it's the entire setup or it's just a pod for a separate application that you need to run. One bottom installer, and of course, being able to scale as you grow are the benefits of the Hyperconverged solution. So this is just the data center portfolio that we have from Cisco. So we do have blade servers, rack servers, have had it for many years. Those are the hardware platform that we use in our new hyperconverged infrastructure, HyperFlex. We still deliver what we call converged infrastructure with our eco partners like NetApp, IBM, Pure, Nimble, where we have validated design on building traditional setup. We still do deliver that for data centers. But with Hyperconverged, it's actually the first solution where we now can deliver compute and storage and network in one single package. So HyperFlex, we do have two models that we build HyperFlex on. One is the 1U rack server. They cannot hold that many disks internally. We have a 2U where we can actually fit 24 disks on 2U space. And actually, depending on the size of storage that we need to build, we choose either our 1U or 2U and build HyperFlex solution with those. In our current platform, we do support VMware as hypervisor. We are looking at working with others as well. But the main part of being a hypervisor that's in the enterprise setup is one reason to choosing this platform. What we actually build in with HyperFlex is fully redundant solutions. So we just put together servers. We can lose disks without losing data. We can lose entire server nodes still without losing access to the platform. So it's very robust, reliable, and made for the enterprise. So this is actually how a solution could look. So in the middle, I have 4 what we call storage nodes. So these are our 2U rack servers with X numbers of disks, always starting with minimum 6. And in this setup, I've also connected blade servers. They are what we call compute nodes. But all the servers, blades, and rack servers are part of the same cluster. But the flexibility starts small with storage node. If you have compute-intensive application that you need to run and not require that much storage, you can just add, on this screen, shown as blade servers, but you can also just add rack servers not providing storage, but actually having storage for existing storage node in the setup. So what we're actually delivering is an appliance-like solution. So not an appliance that fit all, because we can have some servers set up with a lot of cores. So we do have different types of CPU, different types of memory. But when it is installed in the data center, VMware is pre-configured on the server nodes that I actually order. And all I get is just an installer VM where I provide my information on the networking credentials in the setup, and then I'm actually ready to roll. So we have done installation in less than 2 hours, so it depends on how many nodes that you actually need. but actually one day for installation of HyperFlex, then you're ready to actually move existing VMs to the setup or provisioning VMs for the setup. So the platform connects to our Fabric interconnect. So today we are using 10 gigabit Ethernet connections. Soon we will be providing 40 gigabit as the next generation is implemented in the setup. But in your data center, all planning, optimization of the 10G network for HyperFlex is already done by the installer, by the setup, and we only need a few ports in the production network when we install HyperFlex in the setup. So actually the component, we have our storage network, our Fabric interconnect, where we connect all our storage nodes. This is included in the setup. Whether you want spinning disk or you want all flash, so you actually just install a standard UCS server with the amount of capacity that you need. And then the hypervisor, VMware, is already installed. Use your own VMware licenses or buy them from Cisco, depends on what the setup. And the extra part, the intelligence in the setup, is just a piece of software. It's actually just a virtual machine. It's not integrated into kernel or anything that puts limitation in how we can upgrade, how we can scale. And then this setup is automatically provisioned with the redundancy that you need. I will come back to that. And then you just have one big data store ready to roll your application and your VMs. So we do sell these HyperFlex solutions as bundles. So some can be with 1U if I don't need that much capacity, the 2U if I want to have more capacity, or even combination with storage node and compute nodes only. So it's very flexible in the setup. So that's the hardware part of the solution. So the data platform, as I said, is just a virtual machine running. The thing is that you can scale with compute nodes, storage node, just as you wish. The Hyperconverged software, what we call HX software, is actually a brand new software written for hyperconvergence. One of the big things is that we're using a global distributed log-based file system. So this is where a single server can see the disks it has internally, but is fully aware of the disk in all the other nodes, can read and write from them, as well as the one that's locally. And that's very important for actually being able to scale without compromise for performance. So that's one of the big benefits. One of the other benefits is that this new file-based log file system is capable of actually providing inline deduplication, inline compression, and we do that. At the moment, you can't turn it off. This is how we actually save storage in this solution, but we do it without penalty, and we do it both for hybrid nodes and for all flash nodes. The enterprise features like snapshotting, cloning is also a part of the solution. And it's all integrated, where it's the HX, our global file system, that actually provides snapshotting, provides cloning, because we can do that very intelligent, saving a lot of capacity and not compromise performance in the setup. But these are all features that are enabled in a HyperFlex solution. So let's just see how it actually looks inside a single node. So I do have SSD in a hybrid solution. I use these SSD for all my writes. If data is resided on SSD, I also use them for reads. So this is how we speed up performance. On the spinning disk, this is where I can also read if my data is not in cache on the SSDs, and I can actually do it from all my copies I have in the setup. I'll come back to that. And then there's this controller VM, so fully VAI integrated into VMware. So when we take snapshots in VMware, it's our engine that's actually handling it. When we do cloning, it's the controller VM, our software that handles that. And then there's this I/O visor, so this is actually the main part that handles all the intelligent writes and reads in the setup. So it knows about all the other nodes. It knows about the global file setup and where it's most efficient to actually do writes from VM running on this particular node. It not necessarily needs to write to its own disk because they're busy. It can actually write to other server nodes that are less busy than itself. And that's all automated, balanced in the HyperFlex solution. So the distributed file system. So actually in each node we have a dedicated flash disk for actually the catalog of this global file system. But with this global file system, I can actually access all my copies of data because we do write a copy of all VMs more than once to protect it. And we do that on several nodes. And with this global file system not being something that we have tried to enhance from current file system vendors, but actually build it from bottom up, makes us capable of deliver compression, deduplication, snapshot, cloning without performance penalty in the setup. So how we actually write data. So in our setup, when I do install my HyperFlex solution, I can choose to have 2 copies of data, so that will be on 2 separate nodes, or I can choose to have 3 copies. So I will actually, each time I write, do a write on 3 different nodes to ensure that my reliability and protect against disk failures and node failures in the setup. The recommended part for production is, of course, 3 copies. But when I actually write from a VM, I can write on any of the nodes. So I have 1 copy. And what we actually do is that we do not only write the block that a VM writes on a single node, but in this setup, I've chosen replication factor 3. So for every write, I actually write on 3 nodes in flash disk at the same time. So this is how I protect data. In the setup, we have built-in redundancy. So if I actually have an entire node going down, all my VMs that running on that node will be evacuated to other nodes in the setup. What I actually don't have to do is move any blocks, because from any node, a VM can access the redundant blocks that are not failed and can actually do it from any node in the setup. So built-in resilience with VMware and actually never moving blocks in the setup. And then again, we do actually move block because we do auto balance, we do optimization of performance, but that's something that we do in the background as a batch job for the setup. And of course, if I do restore or fix my broken node, the capacity, the compute, is actually available instantly. And we will use our rebalance to actually try and move data to the new node, move VMs, and utilizing the added power on this new node. But it's all done automatically in the HyperFlex setup. So today, we actually need to start with minimum of 3 nodes. So that's how we handle split brain detection. And typically, for production, have 3 copies of data on 3 different nodes. But I can easily just add extra node. Immediately I have capacity and extra compute and memory for the solution. And we will do rebalancing in the background. So I just build and add extra nodes in my setup. Here it's shown with storage node. And you can even also do a decommission of a single node, actually take it out of the cluster. Maybe you have all the compute or storage and you need to use this server in another job. That's also one thing that is possible with HyperFlex. So today, when I buy a HyperFlex solution, I buy it with VMware, and the license for the HX software is just a service subscription. It's not logged into a single node, but that's the extra cost for the software. When I add nodes, I just buy this HX software subscription for that node. If I, in 3 years, 4 years' time, need to refresh my setup with new generation of servers, I can, of course, use this software subscription model on new hardware. Adding compute nodes doesn't cost anything in the setup, so they're not part of the HX cluster. So what we install on compute nodes is actually just the I/O visor. So the servers that don't have storage actually connect to storage on these storage nodes. And the setup with VMware, today we're using NFS as the protocol to actually access storage in the entire solution. So I can scale with blade servers. So I can buy a chassis with blade servers, or I can just buy, or if I have rack mount servers from Cisco, I can use them as compute node, but they will be part of the cluster. So VMs running on my server nodes can also be evacuated to nodes on the storage setup. It's just not providing storage. So this is just the architecture on how we actually ensure reliability in the solution. So when a VM writes, it goes through this VM, our HX controller VM, and that has the intelligence to write on 3 copies in the setup. As soon as I have acknowledged from my 3 server nodes, all coming from Flash, I do have a commit for the application. But we can use any of the setup to avoid bottlenecks. So of course we also monitor performance when it comes to I/O for disk latency, bandwidth on the networking side, and it's the intelligence in the software that actually chooses the nodes with most performance available. That's where I typically write my data. And of course also avoiding bottlenecks on storage and on networking. So built-in setup where we try to balance each server with the same amount of storage, utilizing the setup and providing the performance is just a built-in setup for the HyperFlex solution. And if I do manually go in and do a vMotion from one host to another, we don't have to move any blocks in the backend because it's visible through our FIs, through our global file system layout. So this is how we build data, ensures resilience in the solution. And I have already spoken about the built-in features. So we do have inline deduplication, compression enable as always on. We don't use any proprietary hardware to being able to service that. So depending in your environment, if it's a greenfield solution where you build everything from a template, the savings are huge. So with deduplication, the same block is only taking up capacity once, and can be referenced from many of the VMs. Of course, in brownfield, where you do migration or you still have savings with both inline compression and deduplication, but with no extra price for actually adding that. And we can do that on all-flash system, and we can also do it on the solution where we use a mix of flash and spinning disks. So adding HyperFlex, I get my hypervisor, my compute, my storage, simple managed solution. If I do have legacy storage already in my environment, we can actually support connecting third-party storage to our Fabric interconnects, whether it's IP-based or it's fiber channel with fiber channel switches connecting to our FIs, and actually give storage from legacy storage into my HyperFlex solution, whether I want to use it when I do migration, whether I want to use it for backup or even production. It's very flexible in delivering capacity to our HyperFlex solution, and if I already have invested in my SAN solutions. So management, we launched HyperFlex March this year, and at that time we only had our plugin for vCenter, because that's where most VMware people want to do all management. So all management is actually delivered via a plugin to VMware. We have just included an HTML5 user interface, which I will show you, because we have found out in the time from March that not all people are that happy with vCenter, and they actually want a separate GUI, so that's actually now available in a tech preview and will be part of the solution in our next upcoming firmware. But this is all managed for you guys that want to sit in vCenter or in just a web browser for all the things you need to monitor, create data stores, expand data stores, make them even smaller, the data stores. Because we are using NFS on a global file system, this is a very valid feature of the setup. So snapshots, I've been into that. Clones for, at least many use this for VDI solutions, or if I have a lot of test and development environment, this is a very neat feature. So one of the customers that we did early beta testing for HyperFlex actually last year, they are now using HyperFlex for the test and development, and they really love they can provision 100 VMs in a few minutes. So that's also part of the solution. Summary. Second generation HyperFlex launched in March. Today we have more than 800 customers running HyperFlex. We actually have customers in all the Nordic region. Based on our log-based file system, we know that we can scale almost with thousands of nodes in a single solution. That's not available today. That requires some more testing. But with this new log-structured file system, we can ensure performance and we can ensure scalability, automatic distribute data for the setup. Today we are using VMware as hypervisor, but we are not logged into VMware. So as I told you, we are looking at other hypervisors for customers that have a preference for others, and that is coming. And again, ensuring that management is an easy part of the setup. So I will just have some time to actually show you HyperFlex. So the first screen I'm showing is the new HTML5 GUI that we deliver with our solutions. So I actually just connect to a cluster management address. That's also redundant in the setup. And of course get immediately status of the setup, how much capacity. Now this is just a lab setup with a minimum capacity of 6 terabyte usable. I've installed this as a greenfield and just provisioned, I think I'm up to 20 VMs from the same template. And this is why the numbers for savings with deduplication are that high. But this just gives me an overview, and of course, resilience. In this setup, I have 3 servers. If I lose one entire server, all my VMs will be running. It will only be writing 2 copies of data now, but I've actually agreed that it can do that. And this resilience actually expands as I put on extra nodes. We do also, of course, monitor performance in the setup, as I actually told you. And these performance are also, of course, available for you to monitor latency, throughput, IOPS. You can do it for the entire cluster. You can get these numbers for a single node if you actually suspect a node is having performance problem with storage. So this is built in, and we do actually save these numbers for 2 years. So I can also go back in time and get my performance statistics if my application owners actually think there has been a problem. And of course, for managing part, so I've just made a single data store, but I can go in and provision new. I can go in and expand it. I can go in and remove storage if there's available in it. I get detailed information on my storage nodes. So in this setup, as I told you, I have 3 nodes. So these are hybrid. So I have 1 flash disk in each node. That's where I do my write and my reads if data is there. And then I have my capacity node where we sometimes actually move data from our cache, our flash disk, onto spinning disks. But this could also today have been all flash if that was what I wanted. One of the big thing that we see and impresses customers is the way that we can very fast install a total data center solution, whether it's for greenfield or actually for a tech refresh. But in this setup, we do have hardware. So we have servers, we have our fabric interconnects, we have disks, we have network cards, and we also have our HX software. So right now we are at our 3rd version of our HX software. And what we have built in is a very, very easy way to do upgrades. I don't have to first upgrade my hardware, software, find out which drivers to use. We actually just deliver a HX upgrade bundle, and then we take care of if there's needed firmware updates together with software update. This is done automatically, and of course non-disruptive as we have redundancy in the setup. Maybe I need to put my ESX host in maintenance mode for some of our upgrades, but that's all handled automatically in the solution. So that's another big benefit, and what Hyperconverged, especially HyperFlex, promise, that easy to install, but as easy to actually do upgrades, which of course is part of the future. So maybe people want to not sit in a HTML5 management tool, but want to actually manage HyperFlex from vCenter. So when you do install HyperFlex, the last thing we do is just install our plugin into vCenter. Then you log in and log out, and we'll actually have a list of all your HyperFlex clusters when you do scroll down to inventory. So in this setup, I only have a single cluster. But if I had many clusters, it could be if I have many sites or actually build my data center on pods. It's all managed in the same GUI. So like we do provide, as you saw in the setup, we just give a summary, a status of the cluster. So again, version I'm running. This is where I have my upgrade cluster button when I get an upgrade package that handles all the installation and upgrading of parts. How many nodes can be tolerated, capacity. And as I told you, performance for IOP, throughput, latency. So this is just status. So where I actually do my typically or weekly or monthly is, of course, if I want to provision data stores. So today we support customers who want to have many data stores. So you can provision, of course, as many as you want. I've just provisioned a single one. I don't have that much capacity, but you can actually choose your setup. I know many best practices is few data stores, and it's, of course, part of the solution. So if I just want to do an edit of the setup, I have 3 terabytes, but I'm only using a few hundred gigabytes, even though I have a lot of VMs made from the same template. I can just go in and say, don't use 4 terabyte for this setup. I only need 3, and it's automatically visible on the data stores for my VMs, and I can now use this capacity. So very easy to use. And just the last thing I want to show. So this is also where I can have a look at performance for the setup, both currently, past, and I can choose the entire storage cluster. So that's the average latency, the throughput, and the IOPS for the solution. Or I can dig down and choose the host that I want to monitor. And gradually actually dig down and see performance in the detailed setup. So yes, this is how easy it is. We actually deliver the management platform that you prefer. You want it in a browser, you want it in vCenter. And with that, we have 4 minutes. So if we have any questions. Yes?
Are the IOPS in thousands, or are you talking 32 IOPS from this machine?
Yes, so this is just my demo setup. I actually only powered out on one at the moment. So we have tested this setup with a just 4K block size. This is on 3 nodes, 75% read, 25% write, all random. And with 3 nodes, I'm at 40 to 50,000 IOPS, and that's all with latency less than 3 milliseconds. We actually having a new sizer coming out in 14 days, where we can, before we actually deliver and we want to size for performance, we can estimate how many nodes, disk, should it be all flash, should it be spinning, depending on the requirements. But this one is not that heavily loaded. Yes?
Is the solution VMware cluster-centric, or can the storage solution span more VMware clusters?
No, so it spanned only one cluster today.
What is the latency requirements?
latency.
Between the clusters, or between the hosts?
The latency is all handled by our Fabric interconnect. So you can tell it that it's an optimized switch, but that's all handled, optimized with the jumper frame, quality of service that's needed for the maximum latency. But today we only support clusters on true Fabric interconnect. So that's just the lower latency that provides. Going onwards, we're also coming out with replication in the solution, and that's when we will see some requirements for minimum bandwidth. I don't know what it will actually be, but that's when that.
So if I want to scan sites.
Yeah. Yes. Then there will be some requirements for. Yeah. There was one more question, I think. The same. Okay. Yeah. So today the HyperFlex solution works as a single cluster. So we do actually have validated design with Veeam and Certo, which both are present today, where we use them for replicating between data centers. That's still asynchronous replication, and best practice for that is we can replicate between data centers with down to 15 minutes of backlog to the replication. But that's all validated with EcoPartner, where they actually handle and have tested the integration. And our own replication you will see coming out this spring. So it's already on the roadmap. Yes, any more questions? So we did it 11. So yeah, thank you for listening.